chlorodreps. I actually colored this on her phylogeny for you so you could see this. So her chlorodrep group is all in green and her melanodrep group is all in red. So you can see that she found a monophyletic group there. Sort of. There's a bit of unresolved polytomy right here. But you can see that she does have separate groups for the most part. And so she's going to talk about those. What are those different groups? What kinds of traits go with each of those groups? And mark these groups on your phylogeny. It won't take you too much time. Also in this section, they'll talk about transitional species. So the idea that there's this great diversity in bill morphology, right? So you've got these thick finch bill kind of things, these thin insectivores, and then you have these bills where you've got a mandible and maxilla, which are totally different lengths. So the upper part is the maxilla, it's really long, and the mandible is this short pointy thing. And so how do you get from bills that are all the same length, top and bottom, to things that are different lengths? That hasn't happened very often in birds, and so the idea that maybe that only happened once here was a pretty prevalent one in the literature. And so that's a real question that she looks at. Let's see what else. Then they talk about the tubular tongue and evolution of diet. So things I'm interested in are going to be the tubular tongue. So you're going to pay attention when you see that kind of stuff and take notes on that. Mark on the tree which ones are tubular tongued versus not, and then we'll do that again on the molecular phylogeny when we do some comparative work. So at this point, you're already starting to develop a really highly annotated tree with notes on traits related to finches versus neotropical honey creepers and the melano and chlorodreps, and then tubular tongues. Let's go back to the paper. So we've gotten through the introduction. Now we're into methods. Let me scroll down just for a second. Okay, so in terms of methods, I don't have much for notes on this section here. Basically, she's going to kind of give you an idea of how she did her scoring, so read through that and see how that's similar or not to what you guys did. And then what types of traits did she reject and why. And then you get into taxon sampling. The only part of this whole taxon sampling section I want you to really look at is in this paragraph here, and that talks about the large number of outgroups and why she chose the ones she did. This is about study design, so that's something I think we care about. And then under anatomical terminology, just don't read that. That's not useful for us, for our purposes. Then phylogenetic analysis, all you need to do is identify what method was used, maximum likelihood, parsimony Bayes. If she used ordered characters, that is where you have where a move from a character state of 0 to 2 is either 1 step or 2 steps. So did she do, did she weight characters or not? Did she order them? And how the support values were determined, right? What's the statistical method for determining her support values? What types of character matrices lead to poorly resolved trees? This is where we're talking about phylogenetics in general. So she's got a section that talks a little bit about that. So think about why that would be true and how that relates to the owl study that you did. Are any of these things true for you in your work? And then you want to think about what did she do about the things that would lead to poorly resolved trees with her data set. How did she address that? And she'll tell you that. Okay, descriptive osteology. This is a massive long section. You're going to read this part 1, not part 2, just part 1. You're just going to read how she scored one character. That's enough. It's a long enough paper already. So basically what you want to be looking at, so this is where they're talking about that, the maxilla on top and the mandible on bottom. Is this an ordered or a weighted character or not? What is the character? You know what, I talked about what a rhamphotheca was, so you should be good there. Okay, then just skip. Skip, skip, skip. We're just going to scroll, scroll, scroll. You've already looked at the figures within here, and that's good enough. You don't need to look at any other explanation. If you were going to repeat the study, then you would read through this, but I'm not going to make you do that now. So you're going to skip all the way over here to 223, which is results. And then they start talking about the character matrix. So some characters were down-weighted. You'll read about why she down-weighted earlier in the paper. Has to do with polymorphism within a taxon or a species and difficulty scoring. In here she talks about why the relationships among the outgroups might not be well resolved. So answer that question. Why is that? Skip the parts that are talking about the weird fossils that didn't lump within the honey creepers. Don't worry about that. We're not going to talk about that. But then go through and mark what type of bill each of the 11 clades has on the tree. Like for instance, and also then tubular tongue. She tells you which clades have tubular tongues, so mark that down if you haven't already. Don't worry about the plantaris muscle. That's a little bit much for us. And I actually have a note here. Skip from here. So I'm on the page with the table. It starts with 2 of the fossil genera, blah, blah, blah. This is about those weird fossils, those outlying fossils. Don't worry about those. I actually have molecular data on some of them. Okay, and then you get into outgroup relationships. That's great. That's just fine. Actually, I think, are we into, no we're not. Okay, keep going through. You've already looked at the figures. You'll be referring to them a whole bunch. Is that more of the, okay. Now in discussion. Okay, here's the tubular tongue part. The plantaris muscle part you're skipping. Okay, discussion. So she's going to talk about why does she think there aren't many morphological traits that distinguish the dreps or honeycreepers from the carduline finches? What is the main trait that does distinguish them? Don't worry about the specifics of the olfactory nerve position, but you should know that the location of a nerve in its path and the path that it follows is not an often varied trait. So that's obviously a big deal, but you don't need to know all the specifics of where exactly it is in the cranium. She talks a little bit about the type of species that might have been the colonizer of the Hawaiian Islands, the progenitor of the Hawaiian honeycreepers. So what kind of traits make a likely colonizer ancestor for the honeycreepers? And then she talks a little bit about the types of hypotheses that exist for the types of species that diverged early within the honeycreepers in terms of bill type. Finches versus insectivores. And she'll talk about evidence from the Galapagos as well. So take good notes there. What are the hypotheses that exist? What is the support for them? What does her study, her results show? What do they support? Which of those hypotheses do they support? So I've highlighted a few things here. This is the part about the nerve, branching pattern. Okay, and you can skim the conclusion part, and then you're good. And that's about all you need. So in the end, you're going to have pretty highly annotated trees because what we're going to do in class is really compare this pattern, right, this tree and the one with the branch lengths. We're going to compare these to the molecular tree that we have. So do we have any other figures for you? Nope, that's good. All right, see you in class.